Okay, so we saw in our feature-based classification approach that we were able to handle cases where we might have very limited user data. And on the other hand, in our matrix factorization approach, we saw that we were able to capture relationships between users and items, and in particular, learn features of those users and those items. And the question is whether we can have some integrated approach to get the benefits of both worlds. So importantly, the features of our classification-based approach or something like that can capture things like context, time of day, what I just saw, user information, past purchases, whereas the features that are discovered from matrix factorization can capture groups of users who behave similarly. So for example, women from Seattle who teach and are also moms. Okay, so a question is how we combine these two different approaches. Well, it's very straightforward. What we can do is we can take a new user for which we have no past purchase information, and we can use just features specified by that user, such as the person's age, gender, and so on, to predict the ratings that that person might have. Likewise, as we get more and more data from that user, we can weigh more heavily on our matrix factorization approach and use those learned features more strongly when we're forming our recommendations. So it's very simple to think about combining the ideas of a user-specified feature-based model with our learned features from matrix factorization, and gradually switch between the two depending on how much data is available from each user or for each product. And this idea of blending models is really popular. And one example of where it's really been shown to have impact in recommender systems was this classic example that we mentioned at the beginning of this module of the Netflix competition. So this competition was a competition for who could provide the best predicted ratings for users on Netflix. And the dataset consisted of 100 million different user ratings of movies. There's almost 18,000 different movies, nearly 500,000 unique users, and the goal was to predict 3 million ratings to the highest accuracy. And the prize was $1 million. So there were a lot of people very interested in competing for this prize. And what we see in this table here is the leading team, and their model actually blended over 100 different models to get their performance. And so this type of ensemble approach we're going to discuss more in the classification module. But this notion of combining models to get performance that exceeds the performance of any of the individual models is a very common and very powerful technique.